We've been working on all different kinds of conversions, and now we're going to get to the ones that really matter the most for you as you head into health professions and nursing. As a patient or as a parent, I get these little containers that let me measure out a volume, and I hope it gives my kid the right amount of, say, allergy medicine, okay? As a provider, you might have something like, I need to make sure I give 110 milligrams. What volume should I tell the parent to administer, or what volume should I administer? And so with dosage, we're going to be converting often between weights and volumes, and just taking all the skills you've had so far and putting them into a little bit different type of problem. One of the crucial things in these dosage problems is just being able to read through them and turn them into the same type of problem that we've been doing over and over and over. What's the given? What's the goal? And find the conversions. That's what we're going to do in every type of problem. So I'm going to work 4 with you, and then you will have a chance to work more in class on the next page. All right. So first problem, you need to administer 110 milligrams of medicine to a patient. You have a liquid that contains 80 milligrams medicine per 2.5 mils. How many, there's my how many milliliters should you use, okay? And I just want to draw your attention to something here. This is the new piece with dosage. 80 milligrams medicine per 2.5 mils, that's going to be a conversion. And you kind of know that, maybe not in dosage context, but we talk about miles per hour, right? When we talk about speed, or kilometers per hour if you're maybe in a different country, that means miles per hour, right? And it's going to be the same here, that I can take this 80 milligrams of medicine and say 80 milligrams of medicine per 2.5 mils. That is a conversion, and that's something that I can use to convert halfway through my problem. Okay, so you want to be able to spot those conversions. Now, given that number and this 110, can we figure out what my given and goal are? So the given, I'm not going to start with a conversion. If you can remember back to some of the other problems we've been doing, we don't start with the conversion. We start with a number that generally has one set of units. So my given is going to be this 110 milligrams of medicine. My goal is the how many. So my goal is milliliters. All right. Now I want to convert whatever units are in the numerator. Milligrams of med have to be the denominator so that they'll cancel. And then I can look and say, hey, does milligrams of med translate or have a conversion to milliliters? And it does, right? It's really important to write those conversions down so they're right there and they're a tool that you can grab. Just like if you're building something or cooking something, you want to have all your tools and ingredients ready so you can just grab them. So look here, milligrams of med, that's going to be the 80. Be really careful that the 80 stays with the medicine. And then 2.5 for my milliliters there. Milliliters is going to be the unit that I have left. 3.44 mils is my answer. And at least in terms of estimating, that makes sense, right? If you came up with, say you had inverted this and came up with 300 mils of medicine, that would seem like an odd amount to give to my child, right? We're usually giving 10-ish mils of medicine to a child. So this is the mils that I'm going to measure out for that patient, okay? Next type of dosage conversion. So let's read through the problem. A child weighs 15.5 kilograms. If the required dose is 10 milligrams medicine per kilogram of body weight, and do you hear that per in there? 10 milligrams of medicine per kilogram of body weight. I can take that as I read it and just rewrite it. 10 milligrams of medicine per means we're dividing by kilogram of body weight. All right, so that is a conversion, and when it says per kilogram, that's going to mean 1 kilogram of body weight. Notice this is really important. I wrote down medicine and body weight. Those are like apples and oranges. They can't cancel each other, so those are going to be separate types of masses. And then I have how many milligrams should be given. Okay, so remember the yellow is my conversion, so my starting point is going to be not a conversion. 15.5 kilograms, and that's the child. And my goal is milligrams. I'm looking for milligrams of medicine, right? So kilograms of the child or the body are going to be in the denominator. Can I convert that to milligrams of med? Yep, one step. And then I just want to copy my numbers carefully. 10 is the milligrams of med, 1 kilogram of the child's body weight. 15.5 times 10 gives me 155 milligrams of the medicine. And again, ballpark, check, right? I haven't been writing my checks, but 3 mils seemed reasonable. 100 milligrams seems reasonable if I know my dosages for Tylenol and ibuprofen and stuff like that at home. So that would be my answer there, okay? Next one down. A child weighs 35.3 pounds. Required dose is 5 milligrams per kilogram. That's how I read that. This is milligrams over kilograms, so let's just rewrite that. 5 mg over kg. And this is that same unit as here. It's just written a little bit differently. So you want to recognize that these are the same thing. This is milligrams of medicine always, and this is kilograms of body weight, and it's always per 1. And then here's my how many milligrams should be given. All right, so I've got my conversion, my tool ready to grab as needed. Start with 35.3 pounds, and I'm trying to get to milligrams of med. All right. Now, as I look at these two units, pounds and milligrams, I don't see those right here, right? So I'm gonna need an extra step as I work this. Can I get from pounds to something else here? Look here, pounds and kilograms. So I can take my pounds, has to be the denominator, and switch it to kilograms. And then I'll be able to take my kilograms and switch it to milligrams. All right, you follow that? So carefully bring your numbers here. 2.20 pounds for every 1 kilogram. And then for every 1 kilogram of body, I need 5 milligrams of medicine. When I work through this problem, multiply your numerators, divide by your denominators, and I get 80.2 milligrams. Kilograms cancel, and that would be milligrams of my medication. All right, again, in the ballpark of that 100-ish milligrams, 100, 1,000 is reasonable masses for most medications, maybe down to 10. So that would be my answer there. All right, last type of dosage problem, and then you'll be able to maybe redo these on your own and bring these other problems to class. Last type of dosage problem we'll look at together. Patient is prescribed 0.500 grams of amoxicillin, which is available in 250 milligram tablets. And the question is, how many tablets do we need? So I know that tablets is what I'm working towards. There's lots of ways to solve these problems. In nursing classes, they'll teach you one way to solve them. I'm just showing you a consistent way. This works for like any discipline. You can set up these conversions. So just make sure you can get the right answer and that the units are clear enough you can hand it to the person next to you, the person on the next shift, whoever it is, and they can see and check your work for you also. So here, I'm going to think about these tablets as a conversion. And again, on these dosage conversions, really what we're looking for is how to read into the problem to find a conversion. So I'm going to say 250 milligrams for every 1 tablet. And that is my new conversion that I'm using in this problem. So if the patient is prescribed 0.5 grams of amoxicillin, and I want to get to tablets, and I have this tablets per milligram, I know I need grams here. Can I go directly from grams to tabs? I don't have that, right? But what can I go from? Grams to milligrams, okay? And then I'll be able to go using that 250 milligrams per 1 tab, and that'll get me to the tablets, all right? Now this gram milligram, I don't know, I forgot. This is a metric to metric conversion. It's all metric units. So anything that's not metric will be given, like our pounds and kilograms, that's given to you, okay? Or have this handy when you're taking a quiz. But metric, you need to be able to figure that out on the fly on your own, okay? So now we're gonna go back to what we know about metric conversions. I wanna come down here. Milligrams is gonna be right here at milli. Grams, where's that gonna be? It's my base unit, okay? And so once I have my 2 units, I'm gonna look left and say 1 gram. And then I'm gonna put a 1 under that gram, and every place after that, I'm going to add a 0 on so that I can see that the conversion is 1 gram is the same as 1,000 milligrams. Come up here, copy it carefully. Don't get your 1,000 in the wrong place. 1 gram, 1,000 milligrams. I set this up. I take my grams, I convert them to milligrams. I take my milligrams, I convert them to tablets, and my answer here ends up being 2 tablets when I do that. If I had accidentally inverted this, maybe I get 2/100ths of a tablet. That seems too small, right? I want to go back and check my work. So you always want to think through and say, hey, do these answers kind of make sense? So this was the metric conversion that I got from my metric here. All right, so we want to be able to know that medicine per mils gets written as a conversion, medicine per kilogram can get written as a conversion, and milligrams per tablet can get written as a conversion. So rework those yourself and bring these problems ready to go next class. That wraps up this chapter, and just notice at the end of each chapter there's also generally going to be a list of terms, and that is a good place to go as you're working on your vocabulary and want to confirm that you know what a word means, or if you need to translate it, put it into terms that match something simpler or another class. Those are there for you. All right, so good job with dosage. Practice away on that.